Good morning, my name is Adriana Franco. Today I present we work in the study of structural and optical properties of the thermochromic silver and copper tetraiodomercurates ceramics. Chromic materials change color when subject to external influence and the stimulus the most studied of the thermochromic photothermica and the electrochromic materials in which and the applied stimulus again the heating, light irradiance and electric field respectively. On the most common application of the chromic material is in the energy saving using then is the belt environment, also offering indoor comfort in case of the building users. In particular, thermochromic materials are those which change their reflective index upon reaching a characteristic transition temperature. This change can be irreversible and continuous over range of temperature with a gradual color change or discontinued on at critical temperature where the transition occurs abruptly. The samples were synthesized from the co-precipitation method. In the DCC analysis result the characteristics of the phase transition of the material are presented. 3 cycles were performed to study the stability of the samples. For thermochromic silver the thermochromic transition is observed at the charcoal minimum the 51 degrees Celsius, which is reversible with hysteresis when cooling. In the second and the third cycle, a tiny shift of the transition peak was detected. The hysteresis is associated with the mechanical risk of the stress between the grain boundaries. Very different variable is observed in the tetraiodomercurate copper. In the first cycle, the minimum was observed at the 69.6 Celsius degree, which is reversible with hysteresis at the 49.70 Celsius degree. A small shoulder is also observed around the 47.8 Celsius degree. While in the second and the third cycle, the peaking hyper when heating at the 75.8 and the 75.5 degrees Celsius, which is reversible in the one packet around the 49.7 Celsius degree. This figure shows the XRD powder of the powders. After 3 cycles of the heating and the cooling in the DCC measurement, the samples were measured by XRD again to study a possible degradation. The powder of the sample, the tetraiodomercurate silver, did not show evident change. However, the powder pattern of the sample, the tetraiodomercurate copper, showed much less index on the broad peaks associated with the lower crystallinity in the sample. In this figure, index powder pattern, the room temperature blue lines and the 9 Celsius grades red lines are shown. It is evident that the absence of the plane width of the combination of the even and odd Miller indices, strain temperature, and it is alpha phase, corresponding to the cubic phase with spaced group. Using thermodiffraction and diffuse reflectance characterization, it was found the thermochromic transition starts as soon as the temperature begins to increase with a reversible value in the cooling process, showing a hysteresis loop in both samples. However, it was observed that for tetraiodomercurate of copper, the bandgap energy switch followed almost the same path when cooling that when heating. This behavior is different from of the thermochromic silver sample, which clearly following different paths, which we relate the coexistence of the alpha and beta phase during the cooling process. Here are some conclusions. Thank you for attention. Goodbye.